I'm Swapnil Mittal. This is our last lab for the class Physics 2211 Section M for Spring 2023, and I am doing the falling slinky experiment. Here's the introduction and the flow of my presentation. I'll have my introduction there, which we already did have. We'll understand the fundamental physics principles involved in this. We'll observe the motion of a slinky with our already given video by Dr. Greco. We'll build a computational model, compare and contrast between things, and I have provided a short summary for the same. Here's the introduction. The blue line is for the observed motion calculated by the tracker app, whereas the predicted line, the orange, is calculated by our closed script code. The fundamental physics principles involved are fairly simple. First is the velocity update formula and the position update formula, and also the formula for F net, which is especially in the case of the slinky, which is the force in by gravity plus the drag force plus the force of slinky, which is almost a spring. The gravitational force is involved and the drag formula is given. The Newton's second law is also involved in this, and the slinky force is the tension force, and it turns into applied force from gravitational force on the top. These are the observations. The mass is calculated to be 0.25 kgs. The initial position is as given. The initial velocity is obviously 0 as it is a free fall. The time of fall is 8.33 seconds and the height is 1.8 meters. Let's watch the video once. As you can see, the slinky is falling from top to bottom until the top part reaches where the bottom part is. Here's a part of my glow script code and also the link attached to my glow script code if you guys want to watch it. Here's the computational model. As you can see, the position of the slinky didn't move for the first 3 seconds and then started falling down. And here's also a visual representation of the same. The predicted and observed motion are almost in the same line. What does this mean? Why does the bottom remain stationary? As you might have observed, this was the most absurd, or I could say a different thing with the slinky, that the top part, until it reached the bottom part didn't start moving. The bottom of the slinky initially remained motionless because of the tension force of the slinky, which is equal and opposite to the force of gravity, cancelling each other out. Once the top of the slinky hits the bottom of the slinky, the forces at play including the force of gravity and the drag force start. The force of gravity is greater than the drag force, causing the slinky to drop and compress. Thank you so much, guys. I know this was a short one, but the experiment wasn't very long, I would say. This semester was really fun, and I hope to see you guys sometime soon. Thank you so much. See ya. Bye.